How's it going? This is Dr. Shulman, and we're going to be going over still in part one, but this is strategies for comparing numbers. I'm going to share my screen and get into it. So the first thing I'm going to do is go through these notes for you guys. So hopefully this stuff is really interesting. If you go into modules, you'll see where we're at. We're still in this first one, which is numbers and operations, natural numbers, whole numbers, integers, rational numbers. I've been showing you some decimals and fractions as well. Why? I think it's really useful. So I know it's a little longer than it needs to be, but that's okay. We're up to knowing strategies for comparing numbers. So the first thing I'm going to do is go to this part of your notebook. We are here. 1D. It'll probably take a while to load because there's a ton in here. Remember, these are shorter than that first one that was forever long because I just wanted to show you so much. And for these, remember, just do which ones you can. Watch the videos to gain more information, gain more knowledge, see how we're doing it. So let's get into it. We're in 1D, strategies for comparing numbers. And let's go into the skills. So this is it. Not a lot of skills, basically lots of comparing numbers. So hopefully this is interesting for you. Let's shorten that. Well, I guess I have to reload the page. That's okay. So we can just start looking at this one while the page loads. All right. We got our friend in art class. In art class, students are mixing black and white paint to make gray paint. Anola mixes 5 cups of black paint and 2 cups of white paint. Kadeem mixes 2 cups of black paint and 1 cup of white paint. Use Anola's and Kadeem's proportions of white paint to determine whose gray paint will be lighter. So this one isn't too crazy. There's stuff in here, but most of the stuff we're going to do is really simple. Just remember for every time there's a fraction, it's just going to be what you want out of the total. Let's try to get back here, see if it works yet again. So we've got 5 cups of black and 2 cups of white. We want out of the total. So you see it even gives us tests there. Like out of the total, what do we need? All right, let me go down to D. Here we go for comparing numbers. So they give it to us right here, what we want out of the total. So that's usually, and I like drawing pictures too, but basically every time they're asking you for a probability or comparisons, it's just always what you want out of the total. Beautiful. So we got our buddy Anola, which is 5 black and 2 white. We got 5 black and 2 white. Then we have our friend Kadeem, which is 2 black and 1 white. So we want Anola's white paint. So the total for Anola is 7, and we want white paint, so that's 2 out of 7. All right, and now we need Kadeem's. So that's Anola. We got our boy Kadeem, which is 1 white. And our total is 2 plus 1, which is 3. So that's Kadeem. So which one's bigger, 2/7 or 1/3? If you're confused about this, right, we can always make them the same denominators. I can multiply this by 3. So Anola's really 6/21s. I can multiply this by 7. And Kadeem is going to be 7/21s. So which one's more white? Well, which is bigger? 1/3 is indeed bigger. And you can teach your students that the alligator always wants to eat the bigger fraction. 1/3 is bigger than 2/7. Kadeem's will be lighter. Ta-da! Ooh, they drew a picture too. They got the fractions. Ooh, and they made the same denominator. Look at that. All right, let's keep it going. So now we've got some conversions. Conversions are great. I always do conversions with like, what are great prompts to do for conversions? We want to convert stuff. So for conversions, the best way to help your students is always do what you want on the top, what you have on the bottom. Because then what you have will cancel and we're left with what we want. What do I mean by that? Whatever we're trying to convert, we're always going to put what we have on the top and the bottom, and the conversions have to be the shared piece. Given the speeds below of each runner, who runs the fastest? All right, well, we've got a mile. We have to figure out how many feet are in a mile, because everything else is feet. So we got our girl Emily, which is at 8 feet per 1 second. So Emily's 8 feet per 1 second. And then we got Tony. Sorry, Jake runs 500. So let's do Emily compared to Jake. So we got Jake, and he's 569 feet in 47 seconds. But I want this in terms of 1 second, or we can multiply this, ready? By 47. So either we divide this by 47, we can just do it per 1 second, that's fine. So one method, we can multiply this by 47 to figure out how many feet she would run in 47, or we divide Jake's by 47 to figure out what it is in 1. So 569 divided by 47, we can use the calculator. So 12.1 feet per second. So far, Jake is faster than Emily. All right, and then we have Stephanie. So she has feet, but her feet are in minutes. So our girl Stephanie runs 564 feet in 1 minute. All right, well, if I want this in seconds, well, this is in 1 minute. I can change this to how many seconds? 60 seconds. But if I divide that, if I'm making this 60, that's fine. I want this to be 1, so I have to divide this by 60 to get 1. So I can divide this side, the 564 divided by 60. Right, and she's 9.4 for 1 second. So far, Emily is at 47. I'm sorry. Emily's at 8. Jake is at 12.1. And Sophia's at 9.4. So far, Jake is the fastest, but we haven't messed with Tony yet. So Tony's got a mile. So I want to convert the mile into feet. So how many feet are in a mile? 5,000 and what? 5280. So we know we got our boy Tony. So he does 1 mile in 405 seconds. So if I want to make this into feet, well, 1 mile is 5,820 feet. And this is 405 seconds. So I want this in 1 second. So I already made that feet, but I have to make this seconds. So I have to divide by 405 on both sides. And 5,820 divided by 405. And we could do the division by hand, but it's okay. We've been doing a lot of it. And this is 14.4. So Tony is the fastest. Now, what did I mean by this, right? What did I mean by what you want over what you have? I might as well just show you. Let's go to my drive. And let's go to this great lesson that you guys can see. There we go. Here's the lesson. I did this a long time ago. So how old are you, but really? So I tell my students that I am I was a much younger man, 900 million seconds. I wish I was those days. So you felt the chart, and I just put a bunch of old babies, which I thought was funny. So we've got our days, so we can estimate days. Then we do the calculations, and then we cheat by looking at an age calculator. But this is how the conversion works. See, look, I want to go to seconds today, right? Here's a great way. let's just go seconds to minutes. I have 60 seconds. We'll just do a simple idea. 60 seconds into minutes, right? How many minutes is that? They go really far, but we're just going to do one little bit. So here we go. So for 60 seconds, so if I have 60 seconds, you always put, when you're building this, what you want on top, right? We want this in minutes, but what you have has to be on the bottom. So 60 seconds, we know 1 minute will equal that. But this does it like 3 times, right? So 60 seconds to 1 minute. So basically what we want is on top, what we have is on the bottom. So 60 seconds is 1 minute. We can cancel this, right? Oh, so let's say we want to know, here's a good conversion. How many seconds is 4 minutes, right? So we have the 4 minutes, right? We put what we want on top, which is seconds. So I put the 60 seconds on top. What do we have? 1 minute on the bottom, right? So you always put what you want on top, what you already have on the bottom, because guess what? These cancel, and we're left with how much time is 4 minutes? 240 seconds. So when you're doing conversions, they're either going to be multiplying or dividing. So let's go backwards, right? So we just did it one way where it's multiplying. And now let's say we want to know, let's say we have 10 minutes and we want to know how many seconds that is, right? 10 minutes, how many seconds is that? So we have 10 minutes. Oh, wait, I just did backwards again. All right, so let's say we have, I don't know, let's say we have 450 seconds and we want to know how many minutes that is. So we put 450 seconds here. Now, what do we have? We have seconds, right? So that's still 60 seconds. Oh, sorry, we have to put what we have on the bottom. We want minutes. So the conversion's still 1 minute on top. And the bottom is 60 seconds. So ready? These are going to cancel and we're left in minutes. That's why it's going to be 450 divided by 60. Those are going to drop. So how many times does 6 go into 45? Well, 6 can't go into 4. 6 can go into 45 8 times. 6 times 8 is 48. Oh, less than that. Sorry about that. It's 6 times 7. We all make mistakes, right? So it's 42 with a 3, 0. Oh, sorry, with a 3, 0, and 6 goes into 30. How many times 5? So there's your answer. It's 7.5. So it's 7.5 minutes. So that is 7 minutes and 30 seconds. Ta-da! So if you want to show students how to do it, there's a website that'll tell them exactly how old they are with leap years and stuff like that. And if you were 1,000,000 hours old, how old are you? And it's just cute pictures. So really cute lesson for students. All right, let's get back into it. Oh, I didn't pick. Who was fastest? It was Tony. Sorry for leaving you in suspense. We got it. We got it. There's it. See, look. Oh, they just did this conversion, which is fine. We didn't have to do any conversions because it was really simple. But this is if you're confused, and this is like the right way to do the conversions. They made them proportions, which is fine. I don't mind. We just divided them. All right, let's keep on keeping on, right? All right, so let's go to the next one. Which is more? All right, let's see what this one looks like. In art class, students are mixing blue and red paint to make purple paint. Malik mixes 1 cup of blue and 2 cups of red. All right, so we got our boy Malik. He got 1 blue, 2 red. Our job is to make that purple. All right, there's our boy Malik. We got our girl Skylar, who mixes 2 cups of blue and 3 cups of red. Okay. Use Malik and Skylar's percent of blue paint to determine which purple will be bluer. So remember, it's what we want over the total. So what is Malik? Malik is 1 blue over 3. So we're gonna go with 33% for our boy Malik. And Skylar is blue, 2 out of 5. And if you're not sure how to do it, we just divide. 5 goes into 2, it can't. 5 can go into 24 times, so this is 40%. To add the percentage, you just take the 0.4, you times it by 100, because I'm having those 2 zeros there, so that's the 40%. Who's bluer? Our girl, Skylar. We did it. Oh, I like the colors. Very nice. This is about 33 because it's 3, continuing. Ta-da. All right. All right, now we got some 2 linear functions. Let's see what we got. So we got Samantha deciding between 2 truck rental companies. Okay, let's figure it out. We got company A. Charges initial fee for $45 plus $3 per mile. I'm making X miles. All right, so now we got company B. And B is $65. 2X. Cool. Let A represent the amount of company A. Oh, and we have X, and let B is for B. Okay, so we got the equations. And how many miles to the, oh, so we just have to set them equal to each other. So A is 45 plus 3X, or we always like to put the X first. So 3X plus 45. And company B is 2X plus 65. Set them equal. So first thing I'm going to do, I always want my X on the left, so I'm going to minus the 2X to both sides. So I got 45 plus 1X. We don't need the 1 anymore, equals 65. Minus 45 on both sides. And we get X equals 20. So the answer is 20 what? Miles. Just miles, not per dollar. All right, so, and if you want to be fancy, we can see it on a graph. 45 plus 3X, boom, and we got 65 plus 2X. And where do they match? They should match at 20. Let's click the dots. There we go. It says 20.4. 20. And how much would that cost? They asked you the cost. It would be $105 where they match. Boom, boom, boom. That's how graphing can help students visualize what's happening too. All right. We did it. They didn't show you the graph, but that's okay. All right, now we have graphically. Oh, I was hoping we get a graph. All right, we got our boy Lamonte moved into a new house. He planted 2 trees in his backyard. The time of planting, tree A was 40 inches tall. So we got A, which is 40. And B was 16. Tree A grew by 2 inches per year. And tree B grew by 8 inches per year. Oh, they wanted it with T for years. And graph each function and determine which tree is taller after 2 years. So we can put the 2 here, but that's fine. So the first one, we start with tree A is 40. And we're going to go up 2 every time. So there we go. Boom. I rose. Look, that's 4, but I want to go 2. So there's 2. All right, well, I guess that's all they leave me. The next one is we're starting at 16. Well, we're going up 8 a year. So that's every year we go up 16 plus 8 is 24. So I believe that is it. 4, 8. Yep, there we go. So we want to know what happens in 2 years. In 2 years, the first one's still taller. So we're talking tree A is how much taller? Okay, so tree A, this 2 years, it is 4, 8, 12 inches taller, right? Because they're 4, 8, 12. We're going with 12 inches taller than tree B. Yes. We did it. We did it. Ooh, you can do it graphically. I like that. There it is. There's my picture. So the table would just be ready 1 year. This one is going to be what? 42. And in 2 years, 44. This one's going to be in 1 year is going to be 24. And in 2 years, this is the graphically way to show it. It's going to be 36. And what is 44 minus 36? Our magic number 8. A is bigger. What? 16, 24. Why is it 32? 32. Oh yeah, 16 plus 16 isn't 36, it is 32. Wow, I had a moment. I had a moment. And the first one is 44 and this one's 32. And that's why it's not 8, it is 12. Sorry, I got it right the first time, but there it is. All right, let's keep going. All right, let's see what this one's. We got compare rate of change. Ooh, this one looks scary. All right, we got our boy Aaron was comparing the price of grapefruit juice at 2 stores. So Aaron can buy 16 bottles. So we're talking store A, we can get 16 bottles of grapefruit juice, which is going to cost us, oh, well, we just don't know how much it is. So we're just going to do X, 16X equals 32, 32. Now we got store B, Aaron gets oh, and so we got B. They don't even give us the B. Okay, that's fine. I'm fine with it. So we gotta, so it just says what happens at 10 and 20. How much more is it? So we just have to figure out how much more it is. So this is in terms of 10 and 20. We have 16. So the first thing I'm going to do is I'm going to divide this by 16 and see how much just one of these are. So X is 16 goes into 32 2 times, I think it's $2.02. Let me just double check that. I did it in my head. 32 times 0.32 divided by 16, $2.02. All right, let's see what happens at B. So store B, we got 10x equals 520. So we divide by 10. So x is it 52 cents? 10 divided by $5.20. Let's see this. So we have the decimal here. When it's already there, there's no decimal in the question, we have to put it there. 10 can't go to 5, so this goes into 5, so that's 50. Yeah, it's 52 cents. So how much more is it at A? Well, $2.02 minus 52 cents. Damn, that is some cheap, sorry, some cheap grapefruit. It's $1.50 cheaper. Wild. We did it. We did it. Oh, they did division too. I like it. I like it. All right, so let's look at some representations of data. Oh, these are box plots. You probably don't have to know this, so I'm going to delete this one. Is there a new problem? Are they all box plots? All right, no, they're not all box plots. But just so you know, that's a box plot. So based on the 2 data sets below complete. Oh, well, we will need to do this for data. So you can think this is just data cut into quarters. And I can show you more about it when we get to data. But basically, when they want the median, it's just this middle line. A box plot, just in case you want to know. And you'll actually see this because all your grades, when you look at your grade book, are always broken down to quartiles. That's the lowest score. This is your first quarter. This is your median or Q2. 50% of your scores. This is Q3, and this is your max. If they ever have little dots, these are outliers, and these are just means it's over 2 standard deviations away from the mean. That's why they're not included. So they're looking for the median. This just means 50% of the scores are on this line. If there's ever an X in this somewhere, that's the mean. They ever little have an X there. All right, the median of set M is 55. Oh, it's greater. No, it's less than. This just means, what does this mean? This means the data is more spread out. There's more spread out. This data is more bunched together. Are they almost the equal spread? I don't know. It's just more scores are right here for this one. This one's more equally spread. The maximum of data, the max is here. The maximum data set M is, the median of data set M is less than that. The maximum of data set M is less than. Okay. They want, I can do more of these, but we'll get there. So let's do a new problem. We did a box plot. Here we go. All right. So we have this data. What's the middle number? What's the middle number? So the first thing you have to do is just put in order. So here's data set P. It's 58, 63, 76, 78, 149. What's the middle number? 76. Here's data set Q. There's a formula for median. Median's always just going to be n plus 1 divided by 2. We have how many data sets? We have 1, 2, 3, 4, 5. Well, what is 5 plus 1 divided by 2? Well, 6 divided by 2 is 3. It's going to be the third term. Ta-da! All right, so here's Q. It's 9, 35, 113, 140, and 148. There's the median for the other one. So the median for data set P is less than. The minimum, the smallest number of data set P is greater than. We did it. Some comparisons for you. Nice. Ooh, they ordered it this way. They did the cross out method. I like it. And there's the minimums, the smallest numbers. All right, let's go. We're comparing rates. A couple more to go. All right, which of the relationships represent a function with a greater rate of change? Okay, so this is an algebra one, right? So, but I might as well show you what it is. So we have y equals 5x plus 4. The rate of change is just this. It's the slope. That's all it means. So we just need one with a greater than 5 slope. So to get the slope, you just need 2 points. If you take any 2 points, we're fine. So for A, to find the slope, you can just do change in y. It's basically rise over run, or delta y over delta x. So we just do y2 minus y1 over x2 minus x1. You pick any points you like. I usually use the first points. So it's going to be y2. So it's a -8 minus a -1 over 4 minus 0. Well, 4 minus 0 is 4. -8 plus 1 is 9. 9 to, well, it's -9. Well, it doesn't matter. It's just absolute value for the rate of change. So this is 4 divided by 9 is 2 1/4. So this is bigger. All right, let's go to B. Here's the slope. We're going to go 1, 2, 3, run over 1, 2, 3, 4. So 2 negatives, right? But it's still going down. It's negative. So fall 1, 2, 3, run over 1, 2, 3, 4. So B, the slope, is going to be -3/4. This is still bigger. All right, let's try C. All right, let's look at C. Sorry. C, I'm just use the first one. 28 minus 10 over 5 minus 2. 28 minus 10 is 18. 5 minus 2 is 3. It's 6. Your answer is C. Might as well look at this one. Rise up 1, 2, 3, 4, 5. Oh, and this one's equal. D is a slope of 5. And if you want to know how to actually draw the line, I'll draw the line for this one. Y equals mx plus b. Your slope is 5, and your y-intercept is 1. So when I graph this, you'll see it's going to be the exact same thing, 5x plus 1. Oh, let's... There it is. Should look exactly the same, and yes, it does. So we know the answer is C. Ta-da! All right, let's keep on trucking. Back. All right, compare rates in context. All right, let's see what this one has. Ooh, this one looks tough. Two health clubs offer different pricing plans for their members. Both health clubs charge a one-time sign-up fee and a monthly fee. So the equation represents B. Okay, so we're starting with B first. That's weird. 59x plus 20. And A is 51x plus 25. Some expensive gyms. I'm a Planet Fitness goer. All right, cost Planet, use the drop down menu. So Planet A cost in monthly membership fees. Then what? Planet A cost blank in monthly membership fee. Oh, so I have to actually find what they're equal to, which is fine. We just want to know how much A is, right? So the first thing I'm going to do is I hate putting the X over here, but I'm going to have to for this problem because I don't want to make it negative and then flip it at the end. So it's 8x. I'm going to minus 20 to both sides. So I have 5 divide by 8 divide by 8. So what does x equal? 5 over 8, right? So 8 goes into 5, it doesn't. 8 goes into 50. 8 times 5 is 40. 8 times 6 is 48. And that's 20. So 8 goes into 20 twice. It's 62 cents more. So, all right. So that's one way we can do it. Let's look at it graphically. I already hate this problem. All right. 51x plus 25. And we got 59x plus 20. Where they a match. It looks like this is where the dot is. I can't even see it. So let's just look at what the answer is. I think it's like 62 cents. So, oh, that's when they're equal. Okay. So, oh, okay. So I think we just have to do it. So in monthly membership, right? So just per month, A is $59 and this, so it's $8. I think this is what they want. I think that we got to do this in steps. $8 more. Yeah. Oh, I have it backwards. All right, let's do another one. That didn't make any sense to me. Sorry. What a weird problem. All right, so scientists are preparing two satellites. Y equals 5,000 X. All right, so that's A represent. Oh, that's B. All right, and A is 96,000 miles in 8 hours. In 8 hours. Okay, so we have to just do this divided by 8. 8 goes into 96,000 how many times? 8 goes into 9 one time. 8 goes into 62, so it's 1,200. So this is 1,200. A is 12. I just had it backwards. So that's 5,000. That's 1,200. So Space Explorer A travels blank miles less than B in 1 hour. So minus 1,200, 0, 0, make that a 4, 3,800 miles less. That's all you had to do. Ta-da! Sweet, sweet. All right. All right, we're almost done. A couple more. Find the y-intercept of each line drawn and compare their values. Okay, so I have A is x plus y equals 5. So we minus the x to both sides. And a big problem, students do 5 minus x to be 4x, but these are different. We can't subtract them, so it's negative x plus 5. So this intercept is 5. Now, this y-intercept is just when x is 0. When x is 0, we get the y-intercept. So B is actually going to be 3. If we wanted to graph this one, we can. Y equals blank x plus 3. And to get this, we just need the slope. So 3 minus 2 over 0 minus a minus 1. So this is 1 over 1. So it's just 1x plus 3. And those are the two lines. So the y-intercept of A is positive 5. The y-intercept and the y-intercept of B is positive 3. Therefore, A is greater than. We have both equations too, and you should always show your students what the equations actually look like. Let me reload this. So it starts fresh. Negative x plus 5. Notice you don't need the piece here, and this one is going to be x plus 3. And you could actually have your students do what? Plot all the points. You can see that every single point on here, like -4 and -1, is on it. So let's make sure -4, comma, -1. Oh my God, it's right there. They're all going to be right there on the line, and this is where they equal each other. Oh, I didn't answer it. Sorry for leaving you in anticipation. Ta-da! All right, volumes of water tanks. I'm excited. Whatever this is. Two containers designed to hold water are side by side. All right, I'll do my best. They look like jars. Container A has a radius of 12 feet. And container B, and a height of 18 feet. And B has a radius of 13 and a height of 15 feet. Container A is full of water and the water is pumped. Whoa, and so the water is going from here to here? That's crazy. Until it's full. After pumping is complete. Okay. That is so cool. So do we have any left over? It looks like it. So we have to figure out how much is left over. So if you don't know it, the formula for volume of a cylinder is pi r squared times height, and this one is v equals pi r squared times height. But since we have pi in both, I'm just going to cancel it out. The radius here is 144 times 18. And this one is 15 squared is 225. Oh, sorry, it's 13 squared. So it's 169 times 15. And we're just going to see how much is left over. Okay, so let's see. I could be wrong on this one. You know, I've been wrong on a few of these. 144 times 18, 2592. 169 times 15, 2535. And then we're just going to subtract. So minus, the answer is going to be negative 2592. 57, that's okay. This means we got 57 left over. So let's see if that is the right answer. That's what I'm going with. 57 cubic feet. That's what this stands for, feet cubed. Oh, we have to multiply it by pi? That's... Okay, so I thought since they were both pi, but we're subtracting the values, so you actually have to multiply this by the 3.14 and then multiply this by 3.14. Isn't that a shame? So that's okay. So that's how you do it. I'm just mad about it. Is there a better one? Oh, it's the same problem. We might as well get the right answer though. This gives us the diameter. So the first one's, so B equals pi r squared h. So this is 3.14. Half of 18 is 9. 9 squared times 17. So here we go. Clear. Pi times 81 times 17. 4,325 and 97. All right, let's do the other one. The other one is 8 squared. So it's 64 times pi times 20. And this one is 4,021 and 24. That's all I'm rounding it to. So we're going to minus 4325.97. And there's the answer. 304. Do they want it to the nearest what? No. To the nearest tenth. So it's 304.7. We might as well watch the water go. Woo! 304.7. Let's see. What? Oh, they wanted the percentage. There's what we got, 304.7. And then that's not what they asked us for. They asked for what is the percent that it's full. So once we have the 304.7, we have to do this out of the total. Oh my God. What is the volume of the empty proportion of B? All right, so this one we don't have to divide by it at the end, but I'm not going to do it a third time. You can try it yourself. I just got frustrated. Well, I'm still going to do it. 25 times 16 times pi equals 1256.64. The other one is 49 times 14 times pi. And we're going to subtract 1256.64. And they just want to know after pumping. All right. So they don't want the percentage. They want it to the nearest tenth. So 898.5. Ta-da! So there's more left in this one. I mean, what's left over, yeah. So this is how much space is left. Okay, cool. Sorry about that. Let's do the very last one. These are just function values. You won't need this unless you're teaching algebra, but I just thought I'd have it in here for fun for the last one. So they're talking about g of 2, and this is f. So don't be afraid of it. F of x, f of 2, right? But f of x just stands for fancy y. That's all this is. So if we have 2, we're replacing that for x. It's just 3 times 2 squared. So what's 3 times 4? So the first one's 12. All right, let's do the other one. Now g of 2 is 5 times 2, and then there's a little 2 up here. So this is 5 times 2 squared, which is 4, is 20. So we know that the g is bigger than the f. Ta-da! Cool. I hope this was fun for you. Hope you learned some math stuff to be able to teach the young folk. And obviously pass your licensure exam. I gave you harder stuff because I just want you to be prepared and enjoy your day.